And if you had any ones, you should have the definitions of your ones on the back from what you learned throughout the year. Not the year, the chapter. Huh? So what was a conjecture? An educated guess, right? It's some kind of hypothesis. Okay, and then you have to decide if it was true or false. So number 11. If angle 1 and angle 2 are supplementary angles, then angle 1 and angle 2 form a linear pair. True or false? I'm going to say false. Why?
They could be on that.
They could be apart, right? They could be a one on each board, and they're still supplementary. They don't necessarily form a linear pair, right? Because they don't connect. Remember, one false statement makes the whole thing false. So yes, it is true, but we could make it false. So my counter example would be exactly what Hannah said. I'm drawing them in two different places. Everybody agree? I don't understand 12. 12 you would have to plot. Is that quadrilateral or rectangle? You'd have to see if your sides were the same. I won't make it do anything like that. Then we have the logic statements in 2-2. This was and or. What was my up arrow? And my down arrow was or. And were also called what? Conjunctions. Ors, the down arrow was disjunctions. When they ask you to write these, you need to write the sentences with and or in them. That was a big thing that didn't happen on the quiz. Most or some of you tried to still write if-then statements. They're not if-then statements when we're doing these logic statements. So, what does the little squiggly mean in number 14? The opposite of Q, right? The negation of Q. So we would just, what's the easiest way to do a negation? Say not or put a negative in it, right? So, in number 14, after you write the sentence, then you have to decide if it's true or false. If it's an and statement, what has to be true? Both parts have to be true in an and. If it's an or statement, only one of them has to be true. So, everybody think, don't say it out loud so everybody has a chance. What would you say for number 14? Holy cow, it's freezing.
Square yard is not.
Be quiet. Think. Everybody got an answer? All right, now go ahead and sign.
I was gonna say, square yard is not equivalent to 3 square feet, or the sum of the measure of two complementary angles is 180.
Everybody agree? Now, true or false? True? Why?
Because Q's, wait, no. No, it's false.
But one.
R is true, so the whole thing's true. Okay, because it's an or, right? Because the sum of the measures of two complementary angles is 180. That would be false. But a square yard is not equivalent to 3 square feet. Okay? Excellent. Do we need to do 15 and 16? Yes? Is that what you did? All right, 15. Now we're going to do what? And, right? So what would we say? Go ahead.
A plane contains at least 3 collinear points, and the sum of two complementary angles is not 180.
Exactly right. True or false?
False. Wait. No, it's true.
It's true, right? Because now it's an and, so both of them have to be true. And because we negated the second one, then it actually becomes true. Okay? Everybody okay with that? All right, turn the page.
Is there going to be a Venn diagram?
No Venn diagram. The next thing was our conditional statements. remember the conditionals, they talk about writing, if-then statements. The part after if is called my what? Hypothesis. The part after the then is my conclusion. So again, more vocabulary words. So number 18, true or false? If you square an integer, the result is a positive integer. True or false? If I square basically a number, do I get a positive answer? Yes. Doesn't matter if it's negative or positive, right? Integers are positive and negative numbers. Again, vocabulary. Okay. Then if we jump down to 20, they talk about the converse, inverse, and contrapositive. Remember, these were my sentences. So again, I have to first write the conditional, which they gave us at the bottom of number 20, in if-then form if they haven't already. That's my original sentence. And then I go through and I do the three in the order that is given so we stay consistent. If we do it in the order they give us, what is the converse? Again, what did I do? You flip them. You flip-flop the hypothesis and conclusion. Okay, what is the inverse? Negate them, right? But I have to remember to what? Go back to the original sentence. And then negate them. And then my contrapositive would be what? Both, right? Exactly right. Flip it and do that. So, do you want to do this one? Or write it out, I mean? Did you say yes? Alright, so if two angles are congruent, then they have the same degree measure. True or false? True, right? So my conditional is true. And I'm not going to rewrite it because they already wrote it in if-then statement. So what is my converse? Okay, so tell me what you would write. And I'm going to really abbreviate here. If two angles have same measure, then they're congruent. True or false? True again, right? Remember, you have to answer each one of them. If they're true and false. And if they're false, I have to come up with what? Something, right? A counterexample. What is my inverse? So now I have to go back to my original and negate it. If two angles are not congruent, they don't have the same measure. True or false? True again, right? So remember, what has to come about if with my trues and my falses? Okay, in this case, they're all going to be the same, but what pair up? The first and the last, and the second and the third. Exactly right. Okay? And so then my contrapositive, we already know should be what? True. But now we got to just write it. And writing it, we're going to do what? Basically a combo of these two, right? So we're going to switch them and put not. So what would we say? If two angles don't have the same measure? They aren't congruent. Okay? So again, I answer the first one, but I got to make sure this is an if-then, and it was in the book. So we're good. Then answer it. Second one, flip-flop. Third one, go back to the original and negate each. And then the fourth, the contrapositive, is both. But I have to answer every single time. Every time that I have a false, I have to have a counterexample. Okay? Questions with that? I don't think we have any deductive reasoning ones. So this would have been, the law of syllogism and those kind of things. Remember that? I ain't got anything. Good. Good for you, right? We can talk about postulates in section 2-5. But basically a postulate is just telling you a rule, right? So let's go to 2-6 and try some of these proofs. So in 2-6, let's first look at 29 through 32. What property is happening in 29 through 32? Do not say it out loud. Let everybody have a chance. In number 29, how did they go from the first part to the second part? What did they do to the problem? They flipped it. So what did we call that when they just flipped it? Symmetric property. Awesome. Number 30. How did they get to from the first equation to the second equation? What did they do to the problem? Subtraction. Awesome. 31. What did they do on the left-hand side to get to the right-hand side? Distributed, or you really could have said multiplication there. And then number 32, if I have the exact same thing on both sides, reflexive, right? I'm looking in the mirror. Okay? How about 34? So this is the one that we kind of did on the quiz. Well, not this one, but this kind, right? First step in every single proof should be my what?
Given.
The given. Why can I say it? It's given. Again, you shouldn't miss that one. So letter A is given. What did I do in letter B? Multiplication or distributive property. Exactly right. How do I get 6x all by itself? Add 24. Awesome. And how do I get x to be all by itself? Divide by 6. And then again, remember, x equals 11 was my proof statement. Once I get to that, I'm done. But I cannot use prove as my reason why. Even though some of you still tried yesterday. You have to write what you did. So that one would have been division property. Okay? Write a 2-column proof to show that I'm looking at 35 now. If PQ equals RS, and PQ equals RS equals, then X is equal to -10. Let's try this one first together. So, what is my given? PQ is equal to RS. What's PQ?
5x plus 9.
And RS.
X minus 31.
Thank you. So again, this would have been all that was given. What was the proof statement? -10. So again, what's my first step? Taking all of these. So here's the question. Let's just say they switched it and gave me this at the beginning. Okay, so all of this right here is still my first step. And I can say, I can do that because it's given. Right? Or I have to do that for my first step. If they want me to go through this problem and they give me this, what's my next step? But I have to say PQ is equal to RS, and then I would say the definition of congruent segments, right? Everybody agree? Because remember, I need equals if I'm going to do a math problem. Okay? Then what do?
Put the numbers in.
Put the quantities in. 5x plus 9 equals x minus 31. What did we do? We substituted them in there. Awesome. You guys are on fire. How do I get x? Or how do I combine my x's? I'm going to subtract it. If I subtract my x's to one side, I'm going to take my numbers to the other side. So I'm going to subtract 9. So here you got to kind of decide if you're going to do this in one step or two steps. Okay? Which is fine. So 5x minus x. -31 minus 9. And what did we do? We subtracted. Awesome. How do I get x alone? Divided by 4. Divided by 4. X equals, again, look, notice, it is my proof statement. So here again, let's just say for argument's sake that we had this. This would have still been division, right? Because we divided on both sides. But because this isn't the exact same as this, even though we have all the numbers and letters, the last step would be what? Flip-flopping them. And we would say symmetric. Awesome. So even though we kind of switched the problem, remember, those are really key things, and you'll probably have to do each one of those one time. We're on fire. Okay? Any questions there? Let's see if we have a regular one to do. Perfect. Turn the page. Let's go down to 40 through 43 first, or 40 through 42 first, and then we'll come back and do the proofs until we run out of time. Number 40, 41, and 42. Here's again where some of you are running into the problem of not understanding vocabulary. Okay? So anytime that you see that you have a line, what do I know? I got something that adds up to 180. It could be two things. It could be like in the quiz yesterday, how many? There's about 4 or 5 in that one, wasn't there? So it doesn't matter. However many angles make up that linear pair, all equal how much? 180, like Merrick said. What happens if I have the little box by number 5? That tells me it's 90 degrees. So in number 40, easy, I just answered it, right? Number 41, how do I find 6? 180 minus 53. Why? Because it's a linear pair again, right? How do I find 7? They're 53 because they're vertical. Or you could have said 6 and 7 were a linear pair. So once I find 6, I could subtract it from 180. Or I could use the one theorem that said if the same thing are congruent to, supplements of the same thing, then they have to be congruent. Remember that one? I don't remember what the actual number was, but that's what it said. Okay? So obviously you'll say, well, this one's way easier than the ones that you give us on the test, and I can do these all the time. Well, sorry. That's the book. Okay? What's that? What's that, Miss Hine?
I said it's true.
Okay, sorry. Let's go back to 37. Do you want to try this on your own piece of paper? Go ahead. Ryan says no. No, I don't. You go ahead. I'm going to start writing it up here, and then we'll try to get through it together. So, here, ladies and gentlemen, if we run out of time, 38's a good one yet. And then on the other page, number 5 is a good one. If you want to do that for practice, and then just come in and check it in the book. What's that?
What number are we doing?
37. There should be 6 steps. How'd you do in the sign? You have anything written down?
That's about it.
Alright. Let's try it out. First step. Alright? All that stuff. So, again, what's the question? Where do I go, right? Where do I go? Well, I'm going to use this, and I'm going to say what that tells me. X is the midpoint of WY. If it's the midpoint of WY, what do I have that are congruent? Midpoint means that I split something in halves, right? So what are my segments that it split in half? WX is what? Congruent to what? And put your little bars over top, because they're congruent. And let's do the same thing. So I'm going to do this step in the same thing. So what is result from VZ being cut in half? Perfect. Everybody understand what I did there? Again, use the given. Now, the given is all done, so basically, in the back of your mind, we're probably going to do some kind of segment addition here, or subtraction, or something. So that means we're going to do math to it. So if we're going to do math to it, what do we have to do to these? Make them equal. So I'm going to do the exact same letters. And, oh, sorry. What was this first step? Okay. Midpoint theorem or definition of a midpoint. What's my next step? That baby. Okay. Now, where do we want to go? Now let's do segment addition. So again, in the back of my mind, I have to kind of recognize what do I want as my proof. Okay, so if it's helpful, I might come here and I'm going to say, I want this to equal that at the end, right? Maybe that helps. Maybe that shows you what I want to do, okay? So there's got to be something that I can show that those pieces in two different things, all right? So let's do segment addition on the top part, or sorry, on the left-hand side part. What would add up to this whole thing? Because I know what Vx is, and I know what Xz is, and that is a part of each of those big things. So let's add the two pieces together to get that whole thing. And what would I add together? What?
WV equals X.
Equals the whole thing, right? VW plus WX equals that whole thing. Okay? And let's do that both ways. Okay? So now do it from the opposite side and going that way. So and, what? XY plus YZ equals this whole thing, which is XZ. And again, why do I want to do this? Notice in this step right here, what we said it was equal to is in both of those. So that's helpful. All right, and this is the, what? Segment addition. postulate. Alright. Now, notice what I just circled. What I just circled is this and this, but they are what to each other? They're equal to each other. So if these are equal to each other, that means their equations, in a sense, should also be what? Equal to each other. So I'm going to take one of them, and it doesn't matter. I'm going to take one of them and put them in the other's answer. But essentially, I'm just going to take the two problems and set them equal to each other. That makes sense, what I'm saying there? Okay, so we would write what? Wx plus Vw, all I did was flip-flop them, is equal to xy plus yz. Okay? And what did we do? We substituted, right? Now, what's the key to it? Well, if I know that these two things are equal to each other, would it make sense? So in a sense, I'm saying that this is two things that are adding to that are the same thing. So if I know that these are both 3's, and they're added to a 4, if I take those out, what's left over? My two 4's, right? And isn't that what I wanted? Everybody notice that? Okay. So basically, I'm going to subtract out the like terms, wx and xy. So I'm going to have vw is equal to yz because I would have subtracted out wx and xy. Now, in all honesty, they should have probably put one more step in, and I should have substituted again here. Meaning I should have taken and substituted one of those into the other one. So to me, they should have had another step right here before they got to the proof. And actually done another substitution. So, because it doesn't really matter that we know that they're both 3's, we should have shown that. So I would have said, I'm going to call this step 5.5. Wx plus Vw is equal to, I'm going to substitute Wx into xy. Because why? Wx equals xy. And so this would just be another substitution. And then we would get this by doing subtraction, because I'm subtracting out Wx on both sides. And I get my answer. So again, my proof statement was the same, so I know I'm done, and then I just have to have a reason why. Again, the reason why for my proof statement cannot be proved. It has to be some kind of property. Okay? What do you think?
Do one of those?
Yes, you have to do one of those. Not like this, or not. I think it has to deal with linear pairs. No, you're not. No, you are.
No, they cross.
No! Linear pairs form a line.
Yeah.
Two angles.
Line.
You just said they crossed.
I knew it.
Let's try another one. Actually, look right to the right of the one that we just did. See the example 7? Cover up, if you can, the right-hand side of that. And go through those steps and see if you can give the reasons why to each of those steps. Everybody understand what I'm saying? Okay, so cover up the reasons why and see if you can go through that step. Or step by step to get your answer. We need to do lunch. was lunch, anybody know? Kenzie, you on lunch?
Yeah.
Ryan?
Yep.
Dave?
Yep.
Mondo?
Yep.
Cameron?
Yeah.
Bo?
Yep.
Anna? Lauren? Tom?
Yes.
Keith?
No.
Yes?
Yeah.
Aiden?
Yeah.
Thomas?
No.
Meredith? Cora?
Yes.
Alright, how did that one work? Did it work better? Kind of a lot the same, right? Of what we did. So hopefully it helped a little bit. Overnight, because we're running out of time again. Overnight, like I said, you can try 38, 43, and then on the next page is 5. And another one that you could do is this. This one's just from my book, so if you want to write this one down and try another one. Here's another one. The given is Q is the midpoint, PR, R is the midpoint, QS, and your proof statement is, I don't have a proof statement. I would guess that PQ is equal to RS. So there's another one you can work on. So again, try to do another one of these. And don't get frustrated. Have it down the given all the time. You always have the prove, so you have another half a point. And then work from your given. So, like in this one, work from that given. Say what that says. Be obvious again. And then if there's multiple parts of the given, each part of the given should be able to be used in your steps. And then come in and check it in the books over there when you get done.